Hello, students. You are welcome to today's class. Today we'll be considering a question on the homogeneous differential equation. Students always find it difficult to decide whether the question is an homogeneous differential equation or not. Sometimes you carry out a separation of variable directly, but in this case, you have to substitute y equal to vx. How do you know that equation is homogeneous differential equation? Uh, when you have a question like this, x dy over dx equals y plus xy. Let's see a question like that. How do you know whether it's homogeneous or not? Let's always have at the back of your mind that dy over dx equals to f as a function of y over x. What you have at the right hand side must be in the form of y over x. Now let's confirm this before we come to the question. Now divide both sides by x. Now x divided by x dy over dx equals y plus xy over x. X cancel x. Dy over dx equals y plus xy over x. Now divide the numerator and the denominator by the highest power of x. Sometimes you might be having x squared and x. You divide the numerator and the denominator by the one that is having x squared. Is that okay? The highest power of x. Now you now divide it y over x for the first one plus xy over x for the second one, and the denominator x over x. X cancel x equals y over x plus y over x divided by x, that's 1. You can see that you're having y over x, which is the condition we need, but this other one, y, doesn't have over x. That's why it disqualifies this expression, this equation as homogeneous differential equation. This constant one is allowed. Now let's go to the question. Now you're having 2x squared dy over dx equals to x squared plus y squared. Okay? Divide both sides by 2x squared. Let's make it to be in form of dy over dx before we now look for the function in terms of y over x. Cancel out. Now have it will be equal to x squared plus y squared over 2x squared. Now divide it by the highest power of x. X squared is of degree 2, y squared is of degree 2, x squared is of degree 2. Is that okay? Sometimes it might be a mixture of different degree and it's still homogeneous differential equation. What I'm saying that it might be of the form of dy over dx, which is equal to y over x plus y over x squared, different degree, and it's still homogeneous differential equation because it's in form of y over x. Now, since you are dividable side by 2x squared, we are left with dy over dx equals x squared plus y squared over 2x squared divided by the highest power of x, which is x squared over x squared plus y squared over x squared over 2x squared over x squared. X squared cancel x squared, x squared cancel x squared, which is 1 plus y over x, bracket and close, squared over 2. This constant 1 and 2, they are allowed. Y over x is of the form of function of y over x as you have here. It makes it to be a differential equation. Homogeneous differential equation. It confirms it to be an homogeneous differential equation. Now, from what you have here, you having after dividing, you having dy over dx equals x squared plus y squared over 2x squared. You have seen it as an homogeneous differential equation because of the form of y over x when we divide both sides by x squared. Now, from here, you now go into substitution. You go into substitution, substitute y equals to vx. Let's call this one equation 1. In equation 1, you having dy over dx equals x squared. Anywhere you see y, you replace with vx plus vx squared over 2x squared equals to x squared plus v squared. When you square what's in the bracket, x squared over 2x squared. You're having dy over dy over dx to be equals to x squared is common. Let's write it on the other side. We're having dy over dx because x squared is common. X squared into 1 plus v squared over 2x squared. X squared cancels x squared. Allow it 1 plus v squared over 2. Let's call this one equation 2. Okay. Now let's go to what we substituted. Y equals to vx. Want to differentiate it using product rule. Differentiate y equals to vx using product rule. Now you now say dy over dx equals, you keep the v and differentiate the second one first. D of dx of x. When you're using product rule, it's addition that's in between them, plus x dv over dx. Please take note, x is an independent variable and its derivative with itself is always 1. Its derivative with itself is always 1. That's why we're going to put 1 here as we continue. But dv over dx, it will remain the way it is because it's a dependent variable. And its derivative depends on how it varies with x. And because of that, it has no universal value. That's why you have to leave it the way it is. Now, dy over dx equals v into 1 plus x dv over dx, which is equal to v times 1, that's v plus x dv over dx. That's equation 3. That's equation 3. Now say equate equation 3 and equation 2. Equate equation 3 and equation 2. Why are we equating it together and not to equation? And we are not equating it with equation 1 because we have substituted y equal to vx in equation to get equation 2, and also we have differentiated y equal to vx also. Everything is now in terms of v. That's why we put equation 3 and 2 together. We now have v plus x dv over dx equals 1 plus v squared over 2. Take v across equal sign, turn to negative. X dv over dx equals 1 plus v squared over 2 minus v over 1. What's the LCM? LCM is 2. 2 goes in 2, that's 1. 1 times v plus v squared. 2 goes into 1. 1 times 1 plus v squared. You have 1 plus v squared. Okay? Please take note. What we do is that it's like when you are finding the LCM, 2 goes into 1. You multiply with the numerator. The numerator is 1 plus v squared. 2 goes into 1 time. 1 times 1 plus v squared. 1 plus v squared. Minus 1 goes into 2 times v. That is 2v. Now it will now be x dv over dx equals, let's arrange it, v squared minus 2v plus 1 over 2. V squared comes first, followed by minus 2v plus 1. Now, you want to carry out separation of variable now, because in terms of v and x. Now, cross multiply. You now have 2 times x dv, that's 2x dv equals v squared minus 2v plus 1 dx. Now, I want to remove v squared minus 2v plus 1 from the right hand side. Divide both sides by v squared minus 2v plus 1 plus 1. That place now have 2x dv over v squared minus 2v plus 1 equals v squared minus 2v plus 1 dx over v squared minus 2v plus 1. It cancels out. It cancels out. Now, we now have 2x dv over v squared minus 2v plus 1 equals dx. You can see that we're having 2x at this point. We divide both sides by 2x. Divide both sides by 2x. Now have 2x dv over 2x into v squared minus 2v plus 1 equals dx over 2x. 2x cancel 2x. We are left with dv over v squared minus 2v plus 1 equals to now dv here over v squared minus 2v plus 1 equals to dx over 2x. And this one can still be written as 1 over 2x equals to 1 over 2x dx. Now, this v squared can factorize this v squared minus 2x plus 1. Okay. You're having v squared minus 2v plus 1. Want to factorize it. Write it as factorize v squared minus 2v plus 1. When you carry out factorization, what will you get? Look at the coefficient of v squared, it is 1. Multiply with the constant, which is 1, give you 1. Now think of two numbers that when you multiply together, it will give you this 1. And when you add those two numbers together, it will give you the coefficient of v, which is minus 2. And I say, if you say 1 times 1 will give you 1, but when you say 1 plus 1, it will give you 2, and you have minus 2. Let's try minus 1 times minus 1 will give us 1. Negative and negative give us positive. Let's add it also. Minus 1 plus minus 1 give you minus 2, which is what we have as the coefficient of v. Now we're going to make use of, we are going to replace minus 1 to replace, I'm going to use to replace minus 2. Now v squared minus v plus 1. You don't need to put 1v, no. 1v is same thing as v. Okay, in mathematics you don't put 1. Now let's factorize what's common out. What's common is v. I left with v plus v minus, factorize v out, I left 1v minus v goes in v one time minus what's common 1 v negative and positive plus negative 1. So that when you are solving a problem like this, what's in the bracket must be the same. See that you have v minus 1 the same, you pick 1, v minus 1, write the one outside the bracket v minus 1, which is v minus 1 squared, because they are both the same. I'm going to replace v squared minus 2v plus 1 with v minus 1 squared. Now go back, say dv over v minus 1 squared equals 1 over 2x dx. We'll carry out separation of variable. Now integrate both sides. Integrate both sides. Integrate both sides of the equation. All right. Integral of s1 at the front, 1 over v minus 1 squared, because integral of 1 over 2x dx. From here, now let's solve the right hand side of the equation. Let's solve the right hand side of the equation. Don't forget that we have a dv. Now write it as integral of 1 over v minus 1 squared dv. From here, what do you do? Now say let u equals v minus 1. Let u equal to v minus 1. I want to differentiate u and v. Okay. Du dv equals to 1. Differentiation of a constant is 0. Now du now equals to dv. Now go back. Now write integral of 1 over v minus 1 squared dv equals integral of, I'll say let u equals v minus 1 over u. I've represented it squared. Our dv is now du, because everything must be in terms of u. Now, in indices, when you are removing the reciprocal, it will become integral of u raised to power minus 2 du. Now, let's carry out the integration of that, which is equals to u raised to power minus 2 plus 1 over minus 2 plus 1 plus c, because minus 2 plus 1, that's minus 1. U raised to power minus 1 over minus 2 plus 1 is minus 1 plus c, which is equals to minus 1 times 1 over u. When you want to remove negative, turn to 1 over u plus c, which is minus 1 over u which will be minus 1 times 1, that's minus 1 over u plus c. And what do you say our u is? You replace it back, which is equals to minus 1 over v minus 1 plus c. Okay, now we have our integration of 1 over v minus 1 squared is now minus 1 over v minus 1 over v minus 1. Okay, what you now do now, that you now say integral of 1 over v minus 1 squared, integral of v minus 1, integral of 1 over v minus 1 squared dv equals to minus 1 over v minus 1 plus c. Now I now go back and replace it. Okay, now say minus 1 over v minus 1 minus 1 equals to integral of 1 over 2x dx. Now bring 1 over 2 out as a constant. Minus 1 over v minus 1 equals to 1 over 2 integral of 1 over x dx. At this point, our integral of 1 over x equals to ln x. Ln of this x will give us integral of 1 over x. Don't forget, when you differentiate x, we have 1. Now have minus 1 over v minus 1 equals to half ln x plus c. Okay, I'm having minus, take half ln x to the left hand side, minus 1 over v minus 1 turn to negative, minus 1 over 2 ln x equals to c. Now, from y equals to vx, we are having v equals to y over x. You substitute v equal to y over x anywhere you see v. Now, this negative is common, you can bring it out. But before the minus, now be minus, open bracket, 1 over, instead of writing v, that's y over x minus 1 plus, when you bring negative out, you can make what's in the bracket positive, but when you open the bracket, you get your negative back. 1 over 2 ln x close the brackets equals to C. I have to substitute V equals to Y over X anywhere C um, V. Okay. Now let's see what we can do with this fraction. We have in 1 over y over x minus 1 is equal to 1 over, what's this here? That was x. X goes in x1, 1 times y, that's y, minus 1 goes in x times 1, that's x. Okay? It should now be equals to, don't forget that these two are going together. Now be 1 over 1 divided by y minus x over x, which is 1 over 1 times x over y minus 1. Sorry, y minus x. Sorry. It now be x over y minus x. Now you can now rewrite this. Let's say minus, open bracket, x over y minus x plus 1 over 2 ln x, close the bracket, equals to C. This is the end of our class. Thanks for watching. Please don't forget to drop your questions in the comment section. Have a wonderful day.